So, welcome back. After having seen the LV saturation line, after seeing the table 1 and table 2 from the steam tables, now let us try to understand how do we classify a particular system in different zones taking the help of LV line. So, once we know PSAT and TSAT from the LV line, how do they help us to identify a particular system that it lies in this zone or that zone, and that is very important to understand. Let us try to understand zones on the PT diagram using table 1 first, and we will repeat the same exercise using table 2 because both table 1 and table 2 actually help us to identify a particular thermodynamic system, to identify the zone in which it lies. Alright. So, let us come to the PT diagram. As you can see from here, pressure temperature diagram and a LV line which goes from TP to CP. You got a L region and V region over here. On the right side of this LV line, what we have is a superheated vapor zone which is shown over here, and on the left side is the subcooled or compressed liquid zone as shown over here. Also, we know this critical point coordinates, and when the pressure and temperatures are beyond the critical range, that means pressure is beyond the critical pressure and temperature is beyond the critical temperature, we lie in a supercritical fluid zone as shown over here. And also we know that if the system lies on this line, saturated line, we know that it is a two-phase zone. It could be saturated liquid, saturated vapor, or two phases in equilibrium, and that is what we see when this system lies on LV line. So, these are different zones: subcooled compressed liquid zone, superheated vapor zone, and supercritical fluid zone. The question is, if I am given the PT coordinate of any thermodynamic system or state, how do I identify where does it lie, which zone it belongs to, and that is the question right now. So, let us start answering this question, and let us take the reference of table 1 in this case. And when I say table 1, we know now that temperature is the base in that case. So, for any given system now, we have got its PT coordinate, the pressure and temperature coordinates are known to us. We know that the state lies on at a particular pressure and particular temperature, and this is the only given data to us. If we take temperature as a reference, because we are using table 1 right now, I will take temperature as a reference, and corresponding to this temperature, I will be able to find out Psat T. Alright. So, first step is to find Psat T for that given temperature. Once we know this Psat T, the next operation is to compare this value of P with this Psat T, and that is a very simple thing. And with this comparison only, one can find out in which zone the state lies. How do we do this thing now? So, I got different possibilities which I have shown under different serial numbers, and then I do the comparison and identify the zone in which this state lies. Let us say the first state, the first case is here that P is equal to Psat T. So, for a given temperature, I found out Psat T, and we found that P is equal to Psat T. What does it mean? It means that for a given temperature, the corresponding value of Psat T lies over here. That is why the pressure happens to be Psat T over here. It also means that this T is Tsat P, is not it? And the coordinates of this state will be Psat T and Tsat P. And therefore, we say now if P is equal to Psat T, the state lies on the saturation line as shown over here. So, this PT point, this state of any thermodynamic system lies on the LV line. So, it could be a saturated liquid, saturated vapor, or it could be a two-phase mixture in equilibrium, and that is what we can predict. As soon as we know the temperature, find out Psat T, compare this and come to the conclusion that it lies on saturation line as shown over here. The next case is, if I find this P is less than P sat T. So, the given P is less than P sat T, this is P sat T, and you can find out from here that if such a thing exists, that P is less than P sat T, this state lies in a superheated vapor zone now, it is in this condition, and correspondingly we can say that the serial number 2 case is a superheated vapor zone, this state lies in a superheated vapor zone. The third case will be P is more than P sat T. If the pressure, given pressure is more than P sat T, it lies in a subcooled or compressed liquid zone. It can lie anywhere in this zone actually, isn't it? And therefore, we say that it lies in a subcooled or compressed liquid zone. So, we have identified all the three possibilities, the superheated, subcooled as well as two-phase zone. The other one is, we have already mentioned about that thing, which is a supercritical fluid zone, when the P is more than pre-critical and T is more than T critical, the state lies in a supercritical fluid zone, that is in this part over here. So, here in this case, the temperature has to be more than 373.946 degrees centigrade and the pressure has to be more than 22.064 MPa, meaning which you are lying in supercritical fluid zone. So, this is the way that after referring to table 1, from where I get the value of P sat T for a given temperature, and I compare given P with this P sat T and come to different conclusions in order to know in which zone the given state. Thank you very much.